Hello everyone and welcome back. Today we're learning all about the basics of trigonometry. Trigonometry is all about triangles, mostly right triangles. It can be used to find angles, distances, heights, and it has many other applications. Today we are going to focus on how to use the three basic trigonometric ratios: sine, cosine, and tangent. We can use these ratios to find lengths of the sides of a triangle and angles. So let's have a look at the parts of a triangle and what sine, cosine, and tangent are. So when looking at a right triangle and an angle in the right triangle, we have three sides. We have an hypotenuse, the opposite side from the angle, and the adjacent side of the angle. Notice how if we move the angle to the other side, adjacent and opposite change. The first ratio we'll look at is sine. Sine is the opposite side of the angle over the hypotenuse. Cosine is the adjacent side of the angle over the hypotenuse. And tangent is the opposite side over the adjacent side. There's a simple way to remember all of these ratios. If we remember the first letter of each word, for example, sine, opposite, and hypotenuse, we get SOH. With cosine, we get CAH. And with tangent, we get TOA. And that gives us the phrase SOH CAH TOA, which is much easier to remember. Now that we know the ratios of sine, cosine, and tangent, let's look at a right triangle example and put these ratios together. So, as we can see here, we have a right triangle with one angle of 35 degrees, another 55 degrees, and of course the 90 degrees. We have a hypotenuse of 8.5, one side of 7, and one side of 4.9. So let's write out all of these trig ratios so that we can see what these ratios would look like in this triangle. So let's start off with our 35 here. And I'm going to use red for the 35 so we can keep the 35 degrees and the 55 degrees separate. So let's start off with sine. Okay, we'll start off with SO in our SOH CAH TOA. We know that sine is opposite over hypotenuse. So we're going to say sine 35 is equal to the opposite, which is 4.9, over the hypotenuse, which is always opposite your 90 degrees. Okay, so there's one ratio. Now, let's look at cosine. Okay, this ratio will still use the 35 degrees, but this time we're using adjacent and hypotenuse. So my adjacent side is the one close to it. So that's 7 over the hypotenuse of 8.5. And last, let's look at tangent, or TOA. So we'll have tangent 35 degrees is equal to opposite over adjacent. So my opposite side is 4.9 and my adjacent is 7. So these are the basic ratios for this triangle. If you wanted, you could continue on and actually divide the ratios out to get a decimal, which is something we will do later in the lesson. Try to find the ratios of 55 degrees for sine, cosine, and tangent. Pause the video if you need more time. Hopefully you got these answers here. If not, go back and recheck your work. And if you need, watch the example again. These three ratios work for all right triangles. And if you find the ratio in different triangles, you will have the same answers. So let's look at these two triangles I have in the next example and compare the ratios to show that they all have the same value. Let's look at these two similar triangles and prove that these trig ratios are equal in two triangles that actually have different sizes but the same angles. So first, let's start off with sine 35. Let's find the value using a calculator. So if you take your calculator and push sine 35 equals, you should get a value of about 0.57. So now let's look at triangle 1 and find the ratio of sine 35. We know that sine is opposite over hypotenuse, so that's going to give us a ratio of 4.9 over 8.5. Put that in our calculator, and we get about 0.57 again. Okay, let's try it on the second triangle here. Using our 35 angle, we have a ratio of 1.9 over 3.3, and that also equals about 0.57. Now, these are not exactly equal. They're off by a couple of decimals because whenever we're looking at these triangles, I did round the lengths of the sides and the hypotenuse to the nearest tenth of a decimal point. That way, it's just easier to look at. But you can see they're very, very close. And if you do this with all of the angles and all of the ratios, you will find that they are all about equal. So go ahead and pause the video here and see if you can fill out the rest of this table. Hopefully, we got these answers here. Again, some of the slight differences due to the rounding of the side lengths. Knowing and understanding these ratios is an important part of trigonometry. By using these ratios, we can find missing side lengths of a right triangle, as long as we know one side length and an angle. Let's look at these examples here to see what I mean. We want to find the missing side in each of these triangles when we know one of the angles and one of the sides. So let's look at triangle A. So here we have the angle 37. We know one side is 11, and we know the hypotenuse is x. Well, the side that we do know happens to be the adjacent side to the angle. And we also need to know the hypotenuse. So going back to our SOH CAH TOA, we know that the CA is our cosine, and that is the one that uses the adjacent and the hypotenuse. So if we know that cosine 37 is equal to adjacent over hypotenuse, we can say, okay, cosine 37 degrees is equal to my adjacent of 11. My hypotenuse is x. Well, now we're just solving this like an algebraic equation. So let's move our x to the left side and then move our cosine back to the right. So if we divide both sides by x, that gives us x times cosine 37 degrees is equal to 11. Now we can divide by cosine 37 degrees. So that gives me x equals 11 divided by cosine 37 degrees. And if we put that in our calculator, you will come up with the answer, x is equal to about 13.8. So let's look at triangle B. This time, we're working with the opposite side and the adjacent. From our SOH CAH TOA again, we know that TOA is opposite over adjacent, so tangent is the correct ratio we need here. So tangent 32 degrees is equal to opposite over adjacent. So tangent 32 degrees is equal to x over 13. Again, we're going to just solve for x. So multiply both sides by 13. So that will give me 13 times tangent 32 is equal to x. Plug that into your calculator, and we will get the answer of x is equal to about 8.1. So, triangle C, you give it a try. As always, pause the video if you need more time. So hopefully you got x equals 12.9. So now we know how to use the trig ratios to find missing side lengths of a right triangle. We can also use these same ratios to find the missing angles, as long as we know two of the sides. Let's look at these examples to see how we can find these missing angles. With these three triangles, we're looking to find the missing angles theta. Looking at triangle A, we can see that we have theta in the top, and we have the opposite, and we have the adjacent sides that we know. So knowing SOH CAH TOA, opposite and adjacent is tangent. So we're going to write that as tangent of theta is equal to 3 over 3. Now, when we're looking for the angle, our calculators have a function on it that we can use. So most calculators have a second button. So if you hit second and then tangent, you end up with tangent of -1. So what we do is, once we get that function put in, we're going to put our ratio in, hit enter, and that's going to give us theta. So in this case, when we put it in the calculator, we get theta is equal to 45 degrees. Looking at triangle B here, we have missing theta again, and we know the adjacent is 4.4, and we know the hypotenuse is 11. So using adjacent and hypotenuse, we know we will use cosine. So we'll set up our equation as cosine theta is equal to adjacent of 4.4 over the hypotenuse of 11. Again, use the same second or shift key and then hit cosine. And that should give you the cosine of -1. 4.4 over 11 is equal to theta. Push enter. And you should get theta is equal to 66.4 degrees. Go ahead and try C by yourself. Push pause if you need more time. The answer for theta here is 28.8 degrees. The last thing we'll talk about today is what we call solving triangles. All this means is to find the missing angles and the missing side lengths. Sure, we can use the interior angles of a triangle that equal 180 and subtract to find a missing angle, or we could use the Pythagorean theorem, a squared plus b squared equals c squared. But today we're going to use just trig ratios to find these missing values. Let's look at this last example that shows you how to find this. So before I show you how to solve this triangle, how about you give it a try? Use our known trig ratios of sine, cosine, and tangent. Follow the previous examples we've done and find the line segment BC, BA, and angle A. Pause the video if you need more time. When we are asked to solve a triangle, they are just asking us to find the missing sides and the missing angles. So in this right triangle, we already know angle B is 62 degrees. We know angle C is our right angle of 90 degrees. And we know the opposite of angle B is 22.6. So we need to find the adjacent side of B, the hypotenuse, and angle A. When I'm solving triangles, I like to find the sides first. So first, let's look at side BC. So BC, we know, is the adjacent side of the angle B of 62 degrees. Let's go ahead and name this X, just to make it easier for us to find the answer so it's more of a variable than it is the name of a line segment. So to find the adjacent side of angle B, we're going to use tangent. Because we know the opposite, we need the adjacent, so TOA. So we know that tangent of 62 degrees is equal to the opposite of 22.6 over X. Now, just like our previous example, we just solve for X. So move my X over, and that gives me X times tangent 62 degrees is equal to 22.6. Now divide by tangent, and that will give me X equals 22.6 over tangent 62 degrees. Plug that into our calculator, and we get X is equal to about 12.02. So we know line segment BC is 12.02. Next, let's find line segment BA. Now we could use Pythagorean theorem, a squared plus b squared equals c squared, but here we want to use trig ratios to find the missing line. Now that we know the adjacent and the opposite, and we know the angle, we could choose one of two different trig ratios. We could use sine or we could use cosine. What I'm going to use is sine. So let's look at our line segment BA. We know this is the hypotenuse, and let's name this one y. So using sine, let's say, okay, sine 62 degrees is equal to opposite over hypotenuse, so 22.6 over y. Solve for y. Y times sine 62 degrees is equal to 22.6. Y is equal to 22.6 over sine 62 degrees. Put it in our calculator, and we will get a hypotenuse of y equals about 25.60. So last, we're going to find angle A. We could just do 180 degrees minus 62 degrees minus 90 degrees because we know the interior angles are equal to 180, but again, we want to use trig ratios. So to find angle A, we know all of our sides now, so we could really use any of our trig ratios. So let's use the two sides that we just found from angle A, our opposite and hypotenuse. So opposite and hypotenuse we know is sine. So let's say sine of angle A is equal to 12.02 over 25.60. Put that into our calculator. Remember, use the sine of -1 of 12.02 over 25.6. And that's going to give us angle A is equal to about 28 degrees. So hopefully you got these answers. If not, go back and check your work and see where you might have gone wrong. Rewind the video so you can see my work and compare to your own. This is the end of the introduction to trigonometry and the three basic ratios, sine, cosine, and tangent. Hopefully you learned how to find missing angles and missing sides of right triangles today. If you want more practice, please click on the link below and see the worksheet that we've provided. The answers are included, but I suggest that you find the answers yourself and then check the answers that we give you. We'll see you next time with a whole new topic about trigonometry. Have a good one. Bye.